All right, let's see here. Get a couple of these windows open. Let's disable the YouTube chat. Okay. The Twitch. Okay, let me turn this down just a hair, maybe. There we go. Check the input. Okay, looks like we got sound to OBS. So I'm basically just going to work on some bitmap tool stuff. Some folks were asking around in the help with channel the other day about some examples on how to use like the rotate function and a couple other things inside bitmap tools. And I was looking around and I didn't find a great place that does show like examples of just the stuff. There's the docs, right? There's the docs, but we could have some more examples. So let's pull up what we do have. Docs. It'd be nice to have a set of examples like, rotate this, like crop a piece out. I think there's some newer stuff like dithering and some different things that have been added. Be cool to have a spot where, oh, another place to check actually is in the core. In the core there are some tests in the core. Let's say there be bitmap ones. So rotozoom is going to be for rotation, and it does zoom as well, but we will want some examples of just rotation. What I see, is there, that's submodule. Zlib. Where's the Zlib test? Okay, I don't see any kind of like display.io or bitmap tools or anything like that. Okay. So this allows you to it does a bunch of things, honestly. It's a very utility Swiss Army knife type function. It allows you to cut one piece of a bitmap out of a source bitmap and put it into a destination bitmap, but also apply some transformations to it if you want to. So you can do things like rotate it or zoom it to be bigger or smaller, or rotate it and zoom it. And you also get to choose the clips of which part of the source image you want to cut out, and then where you want it to land inside the destination image. So it's kind of like a all-purpose sort of copy-paste from a bitmap type thing going on there. And it is documented here, but I don't know of any good just straight up examples that show how to use it. So I figured I would try to figure that out first of all, and then also publish some examples of it. Nice. Okay. Jump rope. Careful. Yeah, behind you too. So I think probably we start from just getting a bitmap. I think we start with a bitmap from a file. It feels probably best for the examples. Start with a bitmap from a file. So let's go to the display.io guide because there is putting a bitmap inside this, I think. It's purple, which is flowers and stuff. Well, this is on disk. I think we do want. I think we need bitmap, not on disk bitmap. So I think we need to use the image load one. That's like a ESP simple test or something. Purple. I may have this on my device. This is the yeah, I do. Okay. The flowers shows on this page somewhere also, I think. Oh, I guess it doesn't show it, but it's up there in one of the downloads. Purple if you download it here. I think we need a destination bitmap. Yeah, destination bitmap. So let's make another bitmap also, which we're not going to use image load for the second one. We can kind of take from this example. Just creates a bitmap with some colors in it. How many colors? I guess we'll test the length of the palette of the first one. Make it equal to that. Let's keep the tile grid with it for that one. Let's make the next one down here. This one is going to be dest bitmap. I think actually we'll go ahead and make this one source bitmap. Could probably also make the source palette. Palette source bitmap. Yep. So then it's going to get a tile grid. We could call that source tile grid. I guess we may not always have to show the source, because you could also load it and then just cut part out of it, right, and then roto zoom it, put it in a dest, and then show the destination one. You don't actually have to show the beginning one if you don't want, right? So if you're only cutting one piece out, like a sprite sheet or something, you can do that as well. So yeah, let's call this one source tile grid. We don't necessarily need quite that size, do we? Let's make it the size of the source bitmap. Colors, this is the number of colors it's gonna have. We need more than 2. We want to have the length of source palette. Whoops. Yeah. Let's make a dest tile grid. Dest bitmap. Pixel shader will be actually just the same one, honestly. We can just use the palette from the first one. Of course, we could apply some transforms to the palette as well. If you wanted to make like invert palette or something, you do that. We'll just keep the same one. So let's actually show, let's no longer show the source tile grid. Let's run it, it will show nothing. Oh, memory allocation. And 17. Maybe we should use a smaller image. How big is this? 41 by 92? It's a little more reasonable, maybe. Images. Ruby. And then that's 41 by 92. I almost want to make this one just 92 by 92. That way, if we were to like rotate it all the way 90 degrees, it would fit in the destination still. But we could also have it vertical. That should work. And that should be way smaller amount of memory that it needs. Okay, and it's not showing anything. Let's put it back so it shows. Let's see, Ruby. Hello Ruby. Hide that. Instead, let's go group append dest tile grid. Still going to show nothing because we haven't actually put anything in the dest bitmap yet. But now we're all set. We'll see the results of whatever we do put in the dest bitmap, I think. We'll have to see. And so now I think we're ready. We can basically call bitmap tools rotozoom, bitmap tools rotozoom. Oh, don't need that. Destination bitmap. Source bitmap. Oop. OXOY, which is horizontal pixel location in the destination where the source bitmap point is placed. I think we want to go 0, 0. That's basically where we're going to start pasting, top left corner of where we're going to start pasting in the destination bitmap. Next up, dest clip tuple. First corner of rectangular destination, flipping region. The constraints region of writing into destination bitmap. Second corner of rectangular destination, flipping region. So I think this is basically defining the box that we are pasting into. So to start with, I think we're going to try to just let's paste this in without any funny business. So we paste in at 0, 0. This would be dest clip. The first one would be 0, 0. The next one would be width -1, height -1 of the source. I think that's the size that we're copying, so that's the size we want to paste to start with here. We can change it up later. Why is all this yellow? Unexpected argument. Oh, are these all have defaults? These are quarks, actually. Maybe we could leave these defaults. Maybe we don't have to put these right like that first. We did have OX and OI. OI. That does. Oh, we actually did get something. I think. Where'd the camera go? We have part of Ruby. Horizontal pixel location in the source bitmap. Okay, let's play with this a bit, I guess. What does it do if we just changed these? What does it do at like 1010? Actually, I don't know what all these do. Oh, interesting. So if we did half height and width, it would scoot it all the way over, would it? Basically halfway, we saw a quarter of it. Yep, okay. Interesting. So OX and OY. 0, 0 is what we set it on before, and we ended up in the center. Horizontal pixel location, the source bitmap that is placed into the destination bitmap at 0, 0. One thing we should do is say what the defaults do in this. Horizontal pixel location in the source bitmap placed into the dest. So if we had those, on 0, 0, we're gonna kind of save some of these to back to I want to do a different one for now. If we put these back to zeros, and then we set these to zeros, we see the whole thing, or do we still see the quarter? You see the whole thing. Okay, so these like line up with each other, but they default to center point. Interesting. Okay. Let's not mess with clips yet, but instead let's try a angle. Come on. Angle. So nice and easy, let's do 90, but it's not going to be degrees. We need to convert it from radians. I don't know how you do that. Import math. Math. Radians. Degrees. Is that take radians and give back degrees? From radians into degrees. Oh, no, we want to go the other way. Radians, I guess, is what we need then. I don't want to input degrees because I don't think about radians. I don't know how much a radian is really. So radians actually. Converts degrees into radians. F dot radians. Okay. It's 90. Alright, what do we get? We're still in REPL. We get nothing. What do we get when we run it? We get nothing. We don't have these. Interesting. I don't quite get the OX and the PX as much as I thought I did. Zero, I don't. If they were all on zero, I would have expected mostly the same thing. We actually ended up with none. It must be over here or up here. I don't know. We had Okay, so it's over here probably. So if we didn't divide, we would be all the way showing? Nope. You're not showing even further. Strange, yeah, I don't quite get how these work exactly. One which way plus like 10, which way does this move? Got further. So if we did width by itself, would we see the whole thing? No, not quite. Times 2? Still don't think that's the whole thing. Maybe it is, though. Maybe it was. No, I don't think so, actually, because we're still not... There's actually a background in that picture. It's very difficult to see on the screen here. Like those diagonal lines. And it's still touching the edge. We don't have like 10 pixels of margin, so this is not from the edge. Yeah, I don't quite get the relationship of how these work. Especially once you bring the rotation in, I guess. Good news is, though, if you just rotate angle 90, it seems like it works. Let me scoot dest tile grid x equals 10. Okay, yeah. That scooted it off the left wall. Makes sense. So let's distill that, I think, into an example. I mean, rotate 90, and then obviously you could just as easily do 180, 270, or any arbitrary number in between, right? That's the really cool thing about this is you could also just do 45. Whoops, 450 we probably don't want. Crazy snowboarder move. There we go, 45. Realistically, you could, if we want to get crazy with it, you could do something like inside here. You could recall this over and over again. Let's make a... Okay, we'll use a for loop actually. For angle degrees in range 360. All this inside. I guess maybe we need to blank out destination each time. Probably, otherwise those pixels stay there. Let's see what it does. So we're not going to do 45, instead we're going to do angle degrees. Probably we want at least a little bit of sleep in here. Oh, that's pretty good. Okay, doesn't seem like we need to clear it. Oh, let me look at the background. Oh, actually, wow, that's funky on the background, but the foreground... Huh. That is interesting. For whatever reason, I don't know if I'm going to be able to show it very well because of the colors it is. But like the background is smearing around the circle. But why is Ruby herself not smearing around the circle? That's kind of what I expected would happen. But then I guess, so if we did like dest bitmap.fill 0, that should blank it out in between each frame. For one thing, we'll make it choppier probably, but yeah, it should get rid of the background, so may not be able to get it much better than that, but basically now the background is constrained to just that rectangle. We don't have that circle smear going on there. So I guess we kind of lucked out with this particular bitmap in that because of the size and shape of Ruby, the smearing of the background stuff overwrites the smearing of the actual visible Ruby red and legs kind of accidentally. It's kind of funny actually, but I wonder how fast will this go if we don't limit it too fast to like C, or pretty nice actually. Kind of cool. Oh, is that the garbage collector, or is that the camera that hiccuped and not the device? I wonder. I mean, that's pretty good. Oh, I didn't. I was looking at through the camera screen again and not at the actual PyPortal screen. I still don't know if that was like garbage collector pausing the actual playback, or if that was just the camera hiccuping. Every time I am watching the PyPortal, I have not seen it pause. So I'm thinking, I'm kind of leaning towards maybe the camera. Yeah, I don't know. It's been going steady this whole time. I haven't seen it pause. I think that's got to be the camera. It does, yeah, like pause like that. I think that's the camera. Unless, because it seriously, if it did it right after I looked away, that would be crazy, huh? I think it's the camera though. It was smooth the whole time I looked at it, and it felt like longer. I looked at it longer than in between how often it was happening up there. So, so this would actually probably be another good example. It'd be good to show people how to rotate it 90 once or whatever angle again. You know, rotate it any angle and show it, and then just leave it there. That's your intention, but also it might be nice to show people this way of like updating it over and over in order to make this thing rotate like this. So let's work on making this into a example. I actually have, there's a place for examples just like this, which is in CircuitPython.org. There is a thing called built-in module examples. Python module examples. Is made to hold this exact kind of stuff, like example code for, you know, core module built-in stuff. It's not a library thing, so it doesn't really belong with the library repo. Lots of people are not necessarily going to find it inside the core repo, so we could add it to that test folder in the core repo, but people may not find it there. So this is meant to be kind of a place for it. Ultimately, it could go into a learn guide as well. I think bitmap tools could be explained probably in the display.io learn guide ultimately, or potentially even have its own. For now, we'll do this though. So we already have display.io. I think this falls under, I feel like this falls under bitmap tools, even though it does definitely use display.io. But it's really meant to illustrate bitmap tools. Rotate BMP. And the next one we'll call maybe rotate BMP animate or something. These have a more full. Oh. Oops. Didn't leave device workspace open. So this one, I don't want the rotation to keep going. This one I want to just rotate it and show it. Should we, maybe we should show both. Loading soon. I think I like showing them both, and I think I almost want to put even some labels in there that say like source and dest underneath each of them. I want to do that. I guess then it's like it is pulling in a library at that point. Maybe we shouldn't. Yeah, it's meant to be minimal too. Yeah, I don't think maybe we shouldn't have the labels. But we'll comment it up a little bit more, and they do have good names. So anybody who's looking at the code, which again, this is definitely an example code thing, so it's meant for people to look at the code. Anybody doing that should be able to see which one is which. What is this crazy about? Is this redeclared display? I didn't? Did I? Oh, well, it's commented out, I guess. Oh, I didn't comment all this section? Can't get rid of time on this one. We don't need that. I mean, we are using image load library, but that is kind of still integral to what we're trying to show with the rotation. We need to load a bitmap. Show somebody about rotating. We could draw pixels, I guess, and rotate that, but it's, I think this makes it a lot more clear, like what this does, what it can do for you. And the pixels are going to be hard to tell, like, did it rotate or did it just light up a different pixel, right? This is real clear. Like, we got Ruby top ways up, and we got Ruby sideways here, so super clear what's going on. Map rotated image in it. Right, it's not really hold, but like, I guess this one does say hold. It's not really hold, but it's more like show, display. Tile grid is the thing we add to the group is the thing we showed on the display. Therefore, the tile grid helps us show the bitmap. How I think about it. Hold, I kind of think about it as hold too, I guess, though, because it's also like an object with a, you pass it in at the constructor and it holds onto it for you. I can see the, I can see that line of thought as well. With no Ruby folder for that. Well, I guess this one commented. Like I didn't. For what this one? For animation. Okay, so it's gonna maybe show changing colors. Raining. Huh. Be in there. Pretty sure I took this Ruby from Learn Guide. The Portal interface. Use Ruby. I'm gonna use the blue one. Nothing against Ruby. I like blue better than red though. I'm gonna use the blue one. Billy. Minute change. We're tagging in Billy. Alright, Ruby. I mean, maybe we'll use Ruby for the next one. Here, for my device here, I'm just gonna leave the same. Ah, yeah, there. We're gonna need a license for Billy. Fortunately, though, that's where it does get tricky, because we gotta look at the Learn Guide thing. I don't know if this one's gonna have a license, because this one is quite old. And the push to add licenses to stuff is a little bit more recent, so I wonder. Let's check. It's called Portal Interactive? Portal GUI? Cool. Code from Portal user interface. No license here. But this probably, I mean, Billy and Ruby are both different characters. This shows MIT. Feels fairly safe to call them MIT. It would not be me. I guess, I mean, a lot of stuff says Lady Ada. I don't know who, I guess, I mean, the company, I don't know how that works really with all the characters. I definitely know a lot of code stuff does say Lady Ada for the copyright, though. Really, there's those lines in the background. I don't know why those are there. Look back at the original one. I guess they want them to be like that in the original interface. Extra parentheses? Problem. Build? We didn't use them. Is that a problem? Supposed to use them? They quarks? Oh, actually, they don't have defaults. Interesting. That's weird. Well, do they? I guess this doesn't tell us, does it? This doesn't tell us. This is the stubs. I mean, I guess the stubs should tell us, though. But I suppose the reason the stubs don't tell us is the same reason as the reason that the docs don't tell us, which is that the code where it is inside of here, shared bindings, it just doesn't have the defaults in the comments here, right? Isn't that what that means? But extract tuple. Roto zoom. So basically both the docs and the stubs are both pulling from here, and here they're not showing the default. But there must be a default, right? Like, this one defaults to none. And then it says here, in fact, none converts to destination width and height. So we should totally have this in the docs up here. So I think that'll be something we do. Converts to source width. So they do both go to the middle. So we're part of the way there. I still don't quite grok how it interacts with the angle applied also. Quite figuring that part out for sure, but that's okay for now. We also have defaults on these. Angle and scale. Angle defaults to 0. Scale defaults to 1. I think these docs should be like, none. I don't know if that's right. That's probably not right. I don't know the right way, but there should be a syntax for the default value here, and I think putting none, I mean, I suppose none is kind of the ultimate default value in Python for anything, but oh, how's it going, Dexter? Could you put multiple rubies in one larger bitmap? Yeah, you totally could. You totally could. So in fact, our dest should be big enough to do that. Sorry, I didn't see that for a little while over there. I think our dest should be big enough to do it. We could just say we will need to use those. Well, let's start without the angle, first of all. Let's go back to no angle. So that's 2 billies, and so we could just stamp another one like rotozoom again. Same source, same dest. This time, though, we want to manipulate OX and PX somehow, but how is it? Possibly we would use 0 for some of them. Okay, so you can see kind of the idea here. We don't got it right, but we have part of another Billy on there. Something that might make this a little easier is in our dest bitmap, let's find out what these colors are for one thing. This is a long way to get to what we want, but really what I want to see is the color map. Okay, so 1 is white, so I'm gonna fill it with white before we rotozoom anything into it. think that's what that should do. Yeah. Okay, so for the first one, I think we need to shift the P's, maybe? Shift the P's? I'm gonna figure this out one way or another, I guess. PX, would it be higher? So instead of half, we would go up. So maybe the full width, like source bitmap.width. Yeah, let's see what that does. Ah, okay, so that actually scooted it to the left. I wanted to go the other way, so I guess I'm gonna do... zero? Do zero? Yeah, that definitely scooted it to the right. Definitely do not quite get these yet, but this one scooted it to the right. Let's work on the other one now. So here... It's not very good, is it? Maybe we do... Well, it looks like Y we don't want to mess with at all, honestly. Oops. Okay, we're getting close now. We have 2 billies. Okay. There we go. 2 billies. So as long as your destination bitmap is big enough to hold multiple copies, you can stamp multiple copies into it by just calling rotozoom multiple times. Yeah, good question, which we should also have an example showing that. So I'll undo the fill here, and then it goes back to, like, now we just basically have... Because essentially, when I made this, I don't know if when you started watching, but when I made my destination bitmap, I started it as the width of the height of Billy. So Billy is 41 by 92, which at the time I was working with Ruby, but she's the same size. 41 by 92. So then I made the destination bitmap 92 by 92. So I actually have enough room to store it rotated, which in this case also is enough room to store a second copy of it. But we could make it bigger, and we could stamp more copies into it. We could also do 2 copies rotated around or scaled or whatever. Let's try a scale on one of these, actually. So I saw the default scale was zeroed. I mean, was 1. Can we scale down, I wonder? We can scale down? Yeah, for sure. Thanks for the question. Yeah, it's a bit like... I mean, you could almost use it a bit like tile grid in a lot of ways. Like tile grid, in particular, this kind of stuff where you have a sprite sheet and you cut a chunk out of it, and then you paste it into another bitmap that you're going to show on the screen. So, like, you load the sprite sheet into memory, but you never actually show it on the screen directly. Instead, you paste all these pieces that you want into the one you're showing. TileGrid is made to do that. You could kind of do this with RotoZoom as well, with the added benefit of being able to do rotations and scales, clipping, and all kinds of stuff as well. So yeah, it's a very, like, versatile thing. TileGrid is very rigid, where you're very stuck in this exact grid, whereas RotoZoom, you can choose any grid you want. You can just take any arbitrary rectangle, rotate it however you want, scale it however you want, paste it into another one wherever you want. Like, super flexible. Could we go down scale equals 0.5? Ah, yeah, look at that. Got a half-size Billy. Pretty cool, too. Yeah, that's actually really nice, honestly, because without using RotoZoom, we can't scale down in Display.io. We can scale up, but we can only scale up by even multiples also. So, like, we can scale by 2, we can scale by 3, we can scale by 4. We can't just scale by, you know, 1.5 or something, or in this case, 1/2. Do 1.5. It won't quite fit, I think. Yeah, it's a little cut off because we didn't do our destination big enough to fit that, but we could also zoom up by float amounts like that. Now, it'll get a bit fuzzy, of course, if we're zooming up, but, like, that's something we just can't do with just Display.io by itself. Like, you could scale the group, but even multiples only. Should have scale examples too, truthfully. Let's try to commit this one. Okay, it does have pylint, but it does actually have a pre-commit, but it doesn't have actions. Pre-commit run pylint? In black? It sure looks like it, okay. Examples. I think this might not find the right folders though. Also, I'm on your branch from a while ago. Let me go back to go to let's go to Fumigai main. Well, let's make a new branch actually. Ah. Right. Really, I guess the thing we should do specifically on Billy is take the exact license from the Learn Guide, which is the repo where it's from. 2018, and it's under Adafruit Industries. And it is MIT license. Okay. Try one more just by itself. I am actually gonna start keeping copies of stuff, so we're gonna go code here. I have a feeling we're gonna end up with more of these, so. Oop. Okay, so I did put it, instead of inside images, I actually did put it in the root. Oh, it's fine. It's curious what the fill looks like. I don't think we want to have the fill in the example. Okay, so we're exactly in the center of our destination here. So if we wanted to get two rotated 90 like this, we would want to manipulate, I think, the y's, OY and PY. We did PX and OX here. we would manipulate OY and PY, we could end up with two that are rotated. Okay. Take the fill back out though. Or I did it on my device, I guess it's not in the code anyway. Okay. We'll do the animation one. $60. We figured out without sleep was fine. Need. Oop. Oh, we should do probably the. Should do the fill. Just app.fill 0, so it erases. Erase previous preview frame. This way we don't get the smear. First, it doesn't slow it down too much. The fill seems to be a fairly cheap thing. I figured it would take more time. Make this kind of look like it's chunking along. I mean, you know, I don't know. It's no 60 FPS or anything, but pretty fast. Okay. I think we'll just show the, I like the idea of showing the source one actually as well. Kind of like this before and after effect type thing going on. I think I'll keep the source one showing as well, but of course you can do it without the source one showing too. Hopefully that'll be apparent from the examples if you cut out the source tile grid and or just don't add the source tile grid to the group. It is nice that the anchor is the center by default, honestly. That makes it so it's not trying to rotate like up and around here off of the screen. Okay, did I change it any further? I don't think I did. Let's make sure I got enough. Not much different in the way of comments. Changed the main description. This is all the same. We moved our roto zoom down to here. I took its comment with it. Loop over all the degrees. Oh, I did change. I changed the, I did the fill. Go one down like this, so this is like separate. Okay, I'm gonna make a PR to that. If you're around and you're interested, if you want to leave a review or a comment, if you can try this out, or even if you just can take a look over it, or if you've seen me test it here, if you want to leave a review, that'd be awesome. If not, that's cool as well too, though. Let's go map tools, rotate, example plays. Yep, there to main. Maybe we'll take a. I guess we could shoot a quick video. That big. And the hairs and stuff. Got hairs on there. Oh, nice big old smear. That's a new line. Like to have new lines at the end of the files for license one? Sure. Okay, I think I'm gonna head out. Oh, C. Grover, is this compatible with the concept of anchor position? I'm a bit late here for after the start of the stream. Not quite. I wouldn't call it compatible. I would say, well, first of all, bearing in mind I don't quite understand it all the way yet, so take everything I say with definitely a grain of salt, because I don't even understand it fully yet. That being said, based on what I think I understand about it, you can achieve the same things as anchor point and anchor position, the similar concept of being able to move a thing in relation to another thing. But I don't think it is compatible in that I don't think set it the exact same way. For one thing, it doesn't use anchor point as a float, like a decimal. Instead, it wants that OX and that PX to be basically pixels, like 0 to max width and 0 to max height or something like that. And I don't quite get the relation between them, but neither of them are a float, whereas like anchor point, it uses a float. So instead of saying like width over 2, it would be like 0.5 for half. Whereas this would really want that width over 2. So in our case, width is like 40, 41, or 42, and so over 2 would be 20, 21 or 20 or something like that. For a similar UI. Yeah, you could achieve all the same stuff, I think. You could place two things, like two of these paste things, you could place them in relation to each other, using similar sort of placement strategies, but it just won't be the exact same, it's not the exact same values that you would use for anchor point and anchor position if it was like a label or something that had those, yeah. Yeah, but you definitely could, like, based on how I think I get those OX and those PX, it seems like as you manipulate those, you're moving around where your finished thing ends up. I believe you can also manipulate which part of the thing you clip out as well. So you could clip out, just the top half of Billy or something, right? You could clip it out without the legs, or clip out only the legs. That's kind of something you can do as well, and you get pretty fine-grained control over the placement, just slightly different. It's like all by whole pixels, as far as I can tell. Scaling and angling as well, which is super nice. But yeah, I think I'm gonna head out there. So good night, folks. Thanks for hanging out. Appreciate the questions and everything. Hang out for a second because it looks like Seagrover's typing, but get it out here pretty quick. Up with over here. All right. Okay. Nice functionality. Animation appears fairly smooth. Yeah. Yep. The animation looks good in to the direct eye. And this is even only scratching the surface, right? I really only played with angle. I hinted at scale there for a minute. We played with scale for a second. There's a lot more you can do though with scale, and then the clips and all that stuff. So it does lots of neat stuff. And then this is only one thing inside Bitmap tools. There's actually a bunch of other functions that do similar kinds of crazy manipulations and stuff. So hopefully we'll get them all documented up with better examples. I got some stuff to change in the core here too. I'll figure out how to put defaults in this, mention those other behaviors around the defaults too. So yep, thanks folks. Have a good night. I will catch you all next time. Tomorrow for deep dive will be the next time I'm on.